Alright, this is going to be a short tutorial on how to create a spring or coil in Solidworks. So I'm going to start off by making a new part and making sure that I am in metric units. And then I'm going to first make a circle to define my overall diameter of my coil or spring. So I'm going to make a new sketch on the top plane, use my circular tool to make a circle, and I want my overall diameter of my spring to be 25 millimeter. I can exit that sketch, and you see I've got my circle there. I'm then going to go to the Feature tab and go to Curves, and then do the Helix and Spiral. Now if you turn your drawings, you can see that we've started to form a helix shape. We can define this by multiple different ways. We can do pitch and revolution, height and revolution, height and pitch, and spiral. If you do a spiral, it actually doesn't go upwards on the z-axis, it actually just spreads outward. So we don't want to do that. We want to use, for this one I'm going to use height and pitch. So it'll be my overall height of the coil and then the distance between the coil springs themselves. Alright, so when you see we're defining by height and pitch, our parameters, we're initially going to leave it at constant pitch. Our height we're going to set for 100 millimeter, and then our pitch we're going to start off with 6 millimeter. Okay, and then our start angle we want it to start at 0 degrees. So if you, and then we can also change it counterclockwise or clockwise. I'm just going to leave mine clockwise. Just for an example, there is a function here called taper helix. This will come in handy when you start doing your flashlight project. What that will do is actually make a cone-shaped spring. So you'll use that when you're making the spring or the coil for the flashlight battery holder. Okay, but for right now I'm going to leave that unchecked, and I'm going to leave this as clockwise. I'm going to press OK, and you'll see that I've got my spring and coil shape here. Now you will notice this is actually not a drawing. All this is a path, helical path. Okay, we actually need to make the wire that we can revolve and extrude around this path. Okay, so the way that we're going to do that is go into New Sketch, and then we're going to make this sketch on the right plane, and then I'm going to set my view to normal 2, and then go down here towards the bottom, towards the end of this plane, and make a circle. I'm going to set, this is going to be the actual thickness of our wire that's going to be forming our coil. Okay, so I'm going to make that 2 millimeter, and then it might move a little bit, that's okay. We are going to add a relationship between the center point of this circle and the wire itself. So just click on the center point of the circle, hold down Shift, and then select the wire. You'll see we've got these as our selected entities, and we're going to pierce them. And what that does is that makes sure that the edge of this wire, or this path we've got, this helical path, is going to interact with the center point of this circle. So I'll check off on that, and then I'm going to go into the Feature tab and do Sweep, and the face that, or the profile that I'm going to sweep is this circle, and the path that I'm going to follow, I'm going to select that helical path. And you see once we do that, it forms our coil. Click OK, and you see we've got our coil there. Now this isn't a normal coil, this is more of an idler coil because the pitch does not change at all in this. In a normal coil you would see that they're closer together. The pitch is smaller at the top and the bottom, and the pitch is farther apart in the middle. So the way that we're going to do that is we're going to go back into our helix spiral shape and edit that feature, and we're going to change the pitch to variable pitch. Okay, so what you've got here now, we've got 2 points essentially marked right now. Our first point at the bottom and our point at the top. At the bottom our height is going to be set to 0 and our pitch is 6. At the top our height is at 100 millimeter and our pitch is still 6. So that means that our pitch has stayed 6 throughout this entire length of this helix. Okay, what we want to do is change that and edit it and make it so the pitch changes and gets closer together towards the bottom and the top of the coil. So I'm going to make my pitch 2 on that, 2.01, I'm sorry, for the first 3 millimeter, 5 millimeter. I'm going to change it back to 6 millimeter for the pitch. And then I'm going to go all the way up to 95 millimeter. Make that 6 millimeter as well. And then for our fifth, at 97, we're going to adjust back down our pitch back to 2.01 millimeter. And that'll have that. So we'll check off and approve that. And now you'll notice this is more of a spring that you would see out in industry or out in your experiences. So notice that they're closer to, the pitch is smaller and the coils are closer together towards the end of the coil, and they're farther apart, spread out in the middle. Okay. Now the only other thing that we would need to do to make this an actual spring that we could apply to a design, notice that the top and the bottom has a rounded edge on this. Normally you'll see that most of these springs and stuff will have a flat bottom on it, so we can actually apply it and mate it to something. So I'm going to make my right plane viewable and make a new sketch on that one. And then I'm going to set my view to normal 2. And then all I'm going to do is make two squares that kind of go to the halfway center point of that wire, and then go to features and extruded cut. Now we're extruding in the mid plane here. Since we're in the middle of this, we're on that square. I'm going to change to extrude cut from the mid plane, and I'm just going to set it to 25. So actually I'm going to make that 30 so it cuts all the way through. And you'll see that that's given me a flat edge on this coil that I can use. Okay. So that's it for making a spring. If you have any questions, please, as always, feel free to email me or talk to me after class. Thank you.